All right, so today we're still talking about classes and objects because I really want to reinforce that concept. So um, with classes, again, we use classes as a template to create our objects. All right, I want to make that as clear as possible. We use classes to create our templates. So let's pull up the Java Visualizer and let's show you what I'm talking about. All right, so here we have our class. I'm going to call it something else, public class lecture 4, public static void main string args. And then I'm going to just create my class first, another class down here. Public static class vehicle. The vehicle has, let's say, string make, string model. Just two simple variables. All right. So we have a class. And we can use that class now to create several different objects if you want to. Vehicle Mustang equals new vehicle. Mustang.make equals Ford. Mustang.model equals Mustang. Then we can make another vehicle. What's another car? Let's see, Charger equals new vehicle. Charger.make equals Dodge. Charger.model equals Charger. All right, so now we have our two vehicles and we can just do system.out.println just so we'll go through this whole thing. So if I visualize this, sorry, I do need a closing bracket for the full class. If I visualize this, I should create two vehicles, right? Two vehicle objects, one named Mustang and the other one named Charger. And then I'm saying Mustang.make equals Ford, Mustang.model equals Mustang. I'm doing the same thing for Charger. So first thing it does is create this class, right? And now we have a Mustang pointing to an object, a vehicle object. The next line sets the make equal to Ford and the model equal to null. We do the same thing, except now we have an object called Charger, right? A pointer called Charger pointing to a vehicle object. Same thing, we're going to set the make equal to Dodge, the model equal to null. And we can have many different objects. These are just variables pointing to these objects, just like how we can have many different variables of doubles or integers or what strings. Same thing with objects. We can have one or many or none objects depending on what we require, depending on our requirements. So those are how you create the, well, like I said, the classes act as a template, and this is how you create that object of the class, right? And so when I call this method vehicle, new vehicle, it's actually calling a method called the constructor. And that's what we'll talk about today. All right, so let's talk about that constructor method. So when a class is instantiated into an object, the constructor method is called, okay? The constructor. So that's basically the first method that's called when you create an object. It's the constructor. It's constructing the object. It's responsible for creating class variables and setting class variables equal to specific values. So from parameters, either explicitly typed or default data type values. And we'll talk about this. And just be mindful of the constructor name. All right, there's something called the default constructor, right? Which is what is called by default. It has no methods. It has no arguments. It has nothing else in it. It's called when you don't provide any other parameters to a constructor method. So in the absence of a constructor method, or if another constructor method is not provided, the default constructor is called instead. If a class is created without an explicit constructor, class variables are set to their default data type values, No arrays are set to null unless otherwise specified. So if we look at this example, right, just look at my class over here. This class right here, it doesn't have any other methods in it, right? This vehicle class does not have any other methods in it. So a default constructor is called, we just didn't write it. And the default constructor sets all of these variables equal to their default values. So if I go through this, before I set these, they're both equal to null, right? That's the default for a string, null, right? So before I set them, it's set to null. There's nothing else to do. We don't have a constructor in here, all right? So this would be that same example. We have a public class vehicle. We create a vehicle Mustang equals new vehicle, right? We run this line, and make and model are both equal to null, okay? There's no constructor provided, none provided. However, we can create a default constructor method and populate our own values. We can set our own values to that inside of our constructor method. So we can set class variables equal to a default value with literals, so we explicitly type it in here, or set class variables with parameters. So if you look at this new class, right, this class up here, this right here is my constructor now. Public vehicle. And it must match the name of your class. And typically it's public, right? It should always be public for the most part. And inside of this constructor, again, this is a default constructor, this dot make equals Ford, this dot model equals Mustang. And notice when we create this class down here, or this object down here, we're saying new vehicle. And if you look at just this right here, it looks like we're calling a method, which we actually are. We're calling that vehicle constructor method right here. Previously, we didn't type one. So it's just going to call a default method, set everything to null. We didn't create one here. However, now we've created one, so it's actually going to call our method. Right? And do note the use of this keyword. Right? When we say this dot make, we're referring to our class variable. This dot model refers to our class variable. So we have Ford. We're going to set this dot make equal to Ford, this dot model equal to Mustang. So when we run this line, by default, make will be Ford, model will be Mustang. Any questions so far? No. Okay.
You repeat that again, sorry.
All right, so what happens here is when we create our object right here, right? This vehicle, we say new vehicle. What it's doing is calling our constructor method, this public vehicle, right? We wrote it here versus previously, we don't have any constructors in here. We don't have a constructor in this class.
Oh, yeah.
So when we call this one, it's going to set all of these values equal to null or whatever the default is.
Okay.
If they're integers, it's going to set it equal to 0. If it's doubles, it's going to set those equal to 0.
Okay. Okay.
Since these are strings, they're going to be set to null.
Okay.
Whereas here, now we have a constructor that we wrote. So it's going to call that constructor method right here. And this is called the default constructor. And we're going to set this dot make, which refers to our class variable, equals Ford. This dot model equals Mustang. So that this keyword is important because we'll use that again in the future.
Okay. Yeah, I got it. I got it.
You got it?
Thank you.
Mhm. All right. And this is what I talked about. However, the issue with the way we just did it, any object that we create this way, the make and model will be Ford Mustang. Well, we don't necessarily want that, right? Because we can create multiple vehicle objects with different values. So what we can do, instead of saying make and model equals Ford Mustang, we can just say something like none provided, right? That way, when we look at these objects, if we see none provided, we know we haven't provided a make and model yet, right? And we kind of want to avoid those default values, those no values especially, because they can create errors down the road. So instead of Ford Mustang, I'm putting make and model equal none provided. So that when we run this line, we're going to get none provided. So let me show you this over here. So you see our class right here. We have public static class vehicle. We don't have a constructor yet. So let's create a constructor. Very simple, public vehicle. It's just the name of your class. Public, name of your class, parameters, open bracket. And we said this dot make equal to none provided, and this dot model equal to none provided. Nate, wake up. All right. So now we have our constructor method. Public vehicle, this dot make, this dot model. So when I call this up here, by default, our make and model will be none provided. Let's see what I'm talking about. All right, it's creating it. It goes down to our constructor. You see, it went from here now to our constructor. And it's going to set those values. We're going to come back, and now Mustang equals make equals none provided, model none provided. And then we're going to set them equal to the values we want. Same thing with Charger. By default, none provided is what those values will equal. And then we set it to Dodge Charger. All right. So that's our constructor method. We actually wrote the constructor method for this vehicle class. Whereas before, there was none. So by default, it was setting those equal to null. All right. However, we can create constructors with parameters. All right. So that way, the user can put it in based on their input from the console, or you can get it from another part of your program. So when we create this vehicle object, we can set those initial values to whatever we want. So you see here, now I have parameters, string make and string model. Like I said, this dot make, again, that refers to the class variable equal to make, which now refers to this parameter. This dot model refers to the class equals model, which is this parameter. So now when I put these in, when I create these, by default, make and model are going to be Ford Mustang. By default. Same thing with the Tahoe down here. By default, it would be Chevy Tahoe. All right. Let me show you what I'm talking about. So if we instead change this to where we have parameters, string make and string model, we can set this dot make equal to make, which is our parameter, and this dot model equal to model, which again is our parameter. And then up here in our constructor method, we can pass those parameters. So we can get rid of these lines. And now we have this public class vehicle. It has two variables in it, two class variables. This constructor, string make, string model. This dot make equals make, this dot model equals model. So now if I run this, that first line, it'll create Ford Mustang at the beginning, right? And it's passing in this Ford and Mustang to our constructor. So when we create this object, by default, it'll already be Ford Mustang. Same with the Charger. By default, its values would be Dodge Charger because it called our constructor with these parameters. And you see, if you look at our vehicle class, there's nothing in this class that's unique to a specific vehicle type. I had to set that at runtime or through other variables throughout my program. And that makes this vehicle class more general, and you can use this for any type of vehicle, right? Going forward. And there's another thing in programming, your classes can have multiple constructors as well. It doesn't have to just be one, it can have one or many constructors. So here is one with both those constructors. It has a default constructor and it has a constructor with parameters. And so depending on how I create my objects, the compiler will decide which constructor to call. So with this one, it's going to call the default constructor. So make and model will be none provided. With this second line, it's going to call that second constructor. Make and model will be Chevy Tahoe. So let's see this in the code. Public vehicle, this dot make equals none provided. This dot model equals none provided. So if I call this without that right there,
Spell vehicle wrong.
did I? Oh, I should did. Vehicle. Appreciate that. So if I call this first one, it's going to go down to my default constructor, and those values will be none provided. Right? Mustang, make equals none provided, model equals none provided. If I call that second one, it's going to go to that one and set all of those default values. Right? And then we're finished. Any questions about constructors? Because now it's your turn. All right, I want you all to come up with a class. It doesn't matter. Actually, let me show you this in NetBeans, then I'll let you do it. Because NetBeans, you can do it a little bit differently. Right here, I've done everything inside the same file, if you will. But with NetBeans, you can create all this in different files. So lecture 4. And I'll show you what I mean. And this is typically how you want to do it. You want to have your main kind of in a file of its own, so it's in the lecture 4 file. If I go over here to this package, I don't know if you can see that. This package is lecture 4, and it says it right here, package lecture 4. Basically, what folder is it in? It's in lecture 4 folder. If I go over here, I right click, new, Java class, then I type vehicle. And I would use this class to do everything. So string make, string model, and then I have public vehicle. Let me zoom in. This dot make, all right. This dot make equals none provided. This dot model equals none provided. I have another one with parameters, vehicle, string make, string model. This dot make equals make. This dot model equals model. All right. So I have all of this in a separate class, the vehicle class, right? I'm sorry, in a separate file, the vehicle file, vehicle.java. Then from here, I believe you have to import vehicle. Maybe not. That's spell right? Maybe not. I think because we're in the same package, we don't have to. So let's see, vehicle, and if not, NetBeans will tell me. Equals new vehicle. And see, there we go. So now I'm using my vehicle class from this file, right? I don't have this all in the same file, and then I could do vehicle Challenger equals new vehicle. Dodge Challenger. Then let's print out system.out.println Mustang.make plus Mustang.model. Let's see what those values are. Let's do the same thing for our Challenger. Instead of Mustang, let's say Challenger.make Challenger.model. All right. So it should print out not provided, and Dodge Challenger, right? Based on our parameters or based on our constructors over here. The first one is going to call this one. The second one will call this one. Let's see if I'm right. Yep. None provided, Dodge Challenger. All right. And this would tell us, okay, if my output is none provided, I need to obviously provide a make and a model. Right. And I could do this a couple of different ways. I could do it in the constructor, or I could go Mustang.make equals Ford, Mustang.model equals Mustang. Now, if I run this again, we get Ford Mustang. Now, what if we want to read this in from the console? Because that's always important as well. So scanner input equals new scanner. We're going to create a scanner object, system.in, Control-Shift-I. Now we have our scanner object. So instead of make equals Ford, let's say input.nextLine. Input.nextLine. I'm going to prompt the user system.out.println print enter make. Again, I'm going to prompt them again, system.out.print enter the model. So now, instead of me explicitly setting it in my code, now I can read it in from the console. Enter the make. I don't want to do Ford. I want to do, let's see, Chevy. Enter the model. I'm going to say Chevy Camaro. And you see, we read those values in from the console. And although our name of our object, the name of our object is still Mustang, the value of make is Chevy, the value of model is Camaro. Right? So whatever we name our variable doesn't really matter. I can name this vehicle 1. And I'll change this throughout. Vehicle 1. If I run this into the make, let's say a Honda Accord. We're going to print out Honda Accord Dodge Challenger. All right. Another way I could do this is I could read in these variables and then pass them to this object as a parameter like I did down here. So instead of doing it like this, I could do string make, string model. Right now I have two variables holding those values, and I pass it in over here, make model. Same type of code, right? Same thing for the most part. So if I type in Toyota Corolla, make equals Toyota, model would equal Corolla, then we pass those two variables in to our constructor. Does that make sense? All right. Now I want you all to do this with a fruit class. All right, fruit. And then create an apple object. And in the fruit class, like last time, it'll have the int type, not int type, string type, string variety, and then int calories. All right. So 3 class variables. I want you all to create that, and we're going to review it at the end of the class. So make sure you actually do it. You can do it in NetBeans or on the visualizer, either one. So Nate, that'll require you to wake up.
You
We're gonna
said create 3, right?
Yeah, create 3. So string type, string variety, and int calories. We're going to review everybody's at the end of the class, so make sure you do it.
Oh, we doing food? You said calories?
Yeah, a fruit. It's a fruit class.